Hi, I'm Natalie Beeden.
And I'm Kelsey Reardon.
And we're presenting AP Chemistry Free Response question number 1 from year 2006.
Question number 1. Answer the following questions that relate to the solubility of salts of leads and barium. A. A saturated solution is prepared by adding excess PbI2 to distilled water to form 1 liter of solution at 25 degrees Celsius. The concentration of Pb2+ in the saturated solution is found to be 1.3 times 10 to the negative third molar. The chemical equation for the dissolution of PbI2 in water is shown below.
A1. Write the equilibrium constant expression for the equation. First, you're going to say KSP equals, and then you do the concentration of Pb2+ times the concentration of I- squared. And you don't include PbI2 in this because it's a solid, and in your equilibrium expression you only want to have aqueous ions or gases.
A2. Calculate the molar concentration of I- in the solution. So for this you would use an ICE calculation. So you start with the equation PbI2 giving Pb2+ and 2I-. And so initially you have 0, and then your change is x for Pb2+ because it has a coefficient of 1, and 2x for I- because it has a coefficient of 2. Then it's given that the Pb2+ equilibrium molarity is 1.3 times 10 to the negative third. So that's equal to x, and going by that, I- is 2 times 1.3 times 10 to the negative third, which is 2.6 times 10 to the negative third molar.
A3. Calculate the value of the equilibrium constant KSP. So what you do is you put your equilibrium expression back in, which you found in A1. So that's KSP equals Pb2+ concentration times I- concentration squared. And then in A2 you found the numbers, so you found that Pb2+'s concentration is 1.3 times 10 to the negative third molar, and you found that I-'s concentration is 2.6 times 10 to the negative third molar. So now you're going to do 1.3 times 10 to the negative third times 2.6 times 10 to the negative third squared. And that will give you 8.8 times 10 to the negative ninth.
B. A saturated solution is prepared by adding PbI2 to distilled water to form 2 liters of solution at 25 degrees Celsius. What are the molar concentrations of Pb2+ and I- in the solution? Justify your answer. The molar concentrations of Pb2+ and I- are the same as in the 1 liter solution because the concentrations depend on the equilibrium constant, and the equilibrium constant does not depend on volume. It only depends on temperature. So your equilibrium concentrations are the same, and so for Pb2+, it's 1.3 times 10 to the negative third molar, and for I- it's 2.6 times 10 to the negative third molar.
C. Solid NaI is added to a saturated solution of PbI2 at 25 degrees Celsius. Assuming that the volume of the solution does not change, does the molar concentration of Pb2+ in the solution increase, decrease, or remain the same? Justify your answer. The concentration of Pb2+ will decrease according to Le Chatelier's principle. The NaI will dissolve, increasing the concentration of I-, and more I- then combines with Pb2+ to precipitate PbI2. So that the ion product Pb2+ times I- squared will once again attain the value of 8.8 times 10 to the negative ninth.
Basically, since you're going to have more of a product, the backwards reaction is going to be favored, and then the Pb2+ will decrease. D. The value of KSP for the salt BaCrO4 is 1.2 times 10 to the negative 10th. When a 500 milliliter sample of 8.2 times 10 to the negative 6 molar BaNO3 is added to 500 milliliter sample of 8.2 times 10 to the negative 6 molar Na2CrO4, no precipitate is observed. 1. Assuming that volumes are additive, calculate the molar concentrations of Ba2+ and CrO4 2- in the 1 liter of solution. So the new volume is going to be the 500 milliliters of the barium nitrate plus 500 milliliters of sodium chromate, and so the total is 1 liter. And since it says that no precipitate is observed, you use M1V1 equals M2V2, meaning that it's a dilution problem. So for Ba2 plus, when you plug it into the equation, it would be 8.2 times 10 to the negative 6 times 0.5 liters equals M2 times 1 liter. And CrO42 minus would be the same because it has the same molarity, the same initial concentration, and the same final concentration. So when you do the math, you get that Ba2 plus equals CrO42 minus, which equals 4.1 times 10 to the negative 6 molar.
2. Use the molar concentrations of Ba2 plus ions and chromate 2 minus ions as determined above to show why a precipitate does not form. You must include a calculation as part of your answer.
So for this, you're going to do a Q calculation, and Q is the same as KSP except for that it's not at equilibrium. So if Q ends up being less than K, that means that you have less products because Q and K measure how much products you have. So if you have less products, according to Le Chatelier's principle, you're going to increase the forward reaction so that you have more products, increasing the number of ions, and precipitate won't form because that's a reactant. So when you do the Q calculation, you use the same KSP expression, which was Ba2 plus CrO42 minus. And so when you plug that in, you get 1.7 times 10 to the negative 11. So Q is less than K, and so no precipitate forms because ions are being created in the solution.
Thank you for watching. All answers are verified by apscore.org.